Now instantaneous acceleration vector. So we talked about the average. We'll talk about the instantaneous in order to have more information about the motion. So what is this instantaneous acceleration vector? We know that the definition of an acceleration vector won't change. We will have only a new condition or an added condition, which is very small interval of time. Now in this case, we've already seen that A equal delta V over delta t. So the question is how to have a very small interval of time. What do we do? We've seen in this case of velocity, in order to have a very small interval of time, we'll take delta t tends to 0. And this is what we say, adding a condition, delta t tends to 0. Then this means we will have A instantaneous equal limit when delta t tends to 0 for delta v over delta t. So the definition won't change, we only added a condition. Then if we notice and we compare this equation to the equation of derivative in math, we will notice that we'll have the same form. This means we will obtain A instantaneous, which is equal to limit when delta t tends to 0 v final minus v initial over t final minus t initial. This limit with this big variation will give us a small variation of time, and this is what we call dv over dt. By comparing, we know that this form is the form of derivative. Then we deduce that A is the derivative of v with respect to time. This means A equal v prime, it's a vector in terms of I and j, and it's a vector in terms of the time. This means in order to find A1, for example, after finding a vector, we can substitute the time. T equal to 1 second, t equal to 2 seconds, and etc. So we'll have more detailed information about the motion. Now in order to find the value, what are the characteristics of this vector? Point of application is the considered point, means if we want to find a1 vector, then it's m1 a1 according to the name of the object. Line of action and direction, so I leave it like this, since when we find a vector, we will notice the vector we found. If it was in terms of I and j, then it's oblique. So in this case we need to find the angle. If it was only in terms of I, then it's horizontal. If it was only in terms of j, then it will be vertical. So according to the answer we find. In order to find the value, then A equal radical ax squared plus ay squared. As unit, as we said, is meter per second square. Let's do an application, but before we'll have a small revision. A vector equal to v prime, and it's the derivative of v vector, and A equal radical ax squared plus ay squared as value. We continue the application we started with. We have r vector, we have v vector. Now the question is part 7a, determine the acceleration vector at any instant. So when we say at the instant t, this means instantaneous acceleration vector. As we said, in order to find this instantaneous acceleration vector, we'll do a derivative. This means A equal to the derivative of v vector. By deriving, 1 is constant, so its derivative is 0, minus 2t plus 2, minus 2t is of the form ax, then it will be minus 2, and this will be 0. So we'll have as answer minus 2j. Now the question is calculate a1 and a2. We notice that a is independent of the time. This means a1 vector is the same as a2 vector is the same as minus 2j. So in order to calculate the value, we do radical ax squared plus ay squared, then it will be 2 meter per second square. This is a1 and a2. So always in order to calculate, first we find vector, second we deduce the value.